coming through. Coming through, guys, excuse me. Whoa. Oh no, whoa! Alrighty. Looks like we want to listen to the Olga today. That sounds good, awesome. Alrighty, ladies and gents, looking around us. What do we call the red centre? Very rich in iron, isn't it? Yeah. And iron's exposed to water, oxygen and heat. Amazing stuff. This is the oxidising rust. So Uluru and Kata Tjuta, the massive big rusty rock formations. And a single layer of these rock formations can take up to about 450 to 500 years to oxidise and rust over. That aside, we're going to go back in time and touch, let's say about 600 million years or so. No, it's a bit much, but they used to say we had a massive fault line. And they tip right up here. They used to run all the way down from the northwestern areas of Australia, where Broome is, through central Australia, down to where Melbourne, as we see it today. Then a few more running from the top, the Gulf of Carpentaria, all the way down to the Nullarbor Plain, the Great Australian Bight. Hell of a lot of tectonic plate movement, wasn't there? Creating all these basins and bowls all over the place. And two of our largest basins, in our Amadeus Basin, and our Officer Basin. And because there was so much tectonic plate movement, old mate underneath here, he's like, I'll tell you what, I've had enough. I'm sick of being on the lower bunk bed. Are you on the lower bunk bed at home, buddy? He says, I'm sick of this. I want to get up and about. So he pushes that way, he pushes that way. He's like, bit of conflict, back and forth. Oh, look at this. Oh, Issa, how you going? He causes an uplift, an uprising, or a fancy term, an orogeny. And this orogeny's name was the Peterman orogeny, as we can see right here. It was raised out of the ground and was known to be taller than the Himalayas, in over 9,000 metres in height. But there was one problem. It's completely barren and featureless. So what are we supposed to do about this? Nothing was holding it together. To put it in perspective, between Kata Tjuta and Uluru, we have the oldest sand dunes known to mankind. What holds them together? The taproot systems of the spinifex grass, the black cactus, the grey cactus, the witchy bushes right here. Big witchy grub in there, brother. I'll dig one up, you can taste one. Would you like one? Taste it. No, that's under the women's business. I can't do that within this pod, maybe out later on. So the taproot systems hold it together. But this fella was barren and featureless, only lichen, moss and bacteria and such. As a result, they say there was a lot of rain pouring down. A lot of rain. And branch off into these two large basins. Two river systems. And our first river system is very powerful, very rapid. Able to erode boulders up to 1 tonne in size. Was that powerful? Rounding off all these boulders, whilst picking up sediment at the same time. Filling up over here, 27 different types of conglomerate rock, held together by sandstone. What do you reckon this one is? Someone say? What do you reckon this one is? Come on, have a guess. Yes, it's our fruitcake, eh? So that's our fruitcake, Kata Tjuta, or the Olgas, whatever you like to call it. And our next river system, following through. A bit chill, a bit more finer. Picking up the finest sediment, layering up over here. Layer by layer by layer. Oh, hello. There we go. Man, the flies. Layer by layer by layer. And that's our sponge cake with cream water. What is it? The butter and the sugar together, then our dregs, and then your flour. That's our sponge cake and fruit cake. And the reason why I say this is because we need to take our next step. We need to be able to cook these two cakes. They're laid, but they're not yet formed. So they say the inland sea began to recede in about 450 million years ago. And the Earth's core began to heat up. And what have we got? A massive oven now, don't we? Pressure from the inland sea, the Earth's core heating up, cooks out two cakes for today. Kata Tjuta, 27 different types, conglomerate rock, fruit cake. Single arco sandstone, Uluru, our sponge cake, the finest sediment compact over time. But how are we going to get them out of the oven? That's the real question. Feeling a bit peckish now, aren't we? You got your snacks here, you wish that was fruit cake or sponge cake, don't you? We have our second orogeny. Orogeny, once again, meaning mountain building process. The Alice Springs orogeny, they said it occurred 350 million years ago. And there's uplifted the Western and East McDonald Ranges. Anyone heard of this? The Western East Max, yeah. The George Gill Range, where the Kings Canyon is located. Anyone going out to the canyon? Yeah, you'll love the canyon.
Yeah.
It's really spectacular. George Gill Range, the Levi Ranges, the Leo Ranges, the Bairstows, the Mans. There's a hell of a lot of them that you just roll off the canyon. All uplifted. And because it's only 450 kilometres away, what is that, like a centimetre in geographical terms? Placed an immense amount of pressure on Uluru and Kata Tjuta, causing it to warp and bend underneath the ground over thousands of millions of years. And they say with every action, here's the inland sea, and here comes the ranges, oh, seesaw, Marjorie, door, hello. There's an equal and opposite reaction. And because of this, inland sea recedes out, Uluru and Kata Tjuta begin to warp and bend. Remember, they will lay it up like this horizontally. Everyone's still with me, eh? I should have asked that a bit earlier. Uluru flipped out of the ground at an 87 degree angle. And on the way back on the coach, we'll be able to see, fancy term is the stratolators, or the alluvial fan depositories, flipped out of the ground on that 87 degree angle. Ooh, like that. And Kata Tjuta, out on a 15 to 19 degree angle, depending on what dome out of the 36 we're looking at. Remember, Kata Tjuta meaning heads, many heads. And look at the angle. It is theory, of course, but it's quite well rounded. And if you've got another theory, please come up and give it. That's all right. And you might be wondering, why is that solid? Why is the domes all over the place? Conglomerate rock formation. And these two rock formations, a lot of our ranges out here can absorb their own weight in water. We can get up to about 55 degrees out here in the summertime and -7 in the winter. What happens to water? Contracts and expands, doesn't it? Over years, thousands, millions of years, contraction expands, leading to friction, leading to cracks and crannies, leading to water making its way in and amongst, causing river systems breaking away, leading to what we see today. A perfect example of that is what we're left with is the Walpa Gorge. So the Windy Gorge, and when it rains, it's really amazing, but it doesn't ever happen. So there you go, ladies and gents. Any questions on that?